Welcome back, everyone. Make sure to subscribe to my channel for more videos. The topic of this video is applying rules for forming ions. So if you remember from the last video, we talked about these electron energy levels. And if you don't, make sure you go back and watch that video, and the link is posted in the description. So, energy levels, the maximum number of electrons in each level is going to depend on the level that you're in, where you have 2 electrons in that first shell, 8 in the second, and so on. So when we look at the formation of ions, atoms are going to gain or lose electrons in order to form fully filled electron energy levels. So they're going to try to match either that 2, 8, 18, or 32. Okay, and this creates what we call a stable ion. So cations are going to be neutral atoms that have less than 4 valence electrons. And if they have less than 4 valence electrons, it's easier for them to lose electrons and drop down to that lower shell and create a positive charge. So in this example, lithium only has 1 valence electron in its outermost shell because it's in that first group of the periodic table. So it's easier for lithium to lose that electron and donate it to something like fluorine. And when it does so, it only has 2 electrons left, and it becomes positively charged. So that lithium will gain a positive charge, and the electron arrangement that's left is simply 2. Okay, and again, that creates a fully filled first shell. Now, anions are going to be neutral atoms that have 4 or more valence electrons. And those are going to have an easier time gaining electrons and getting a negative charge. And in the example, fluorine already has 7 valence electrons. So if it takes the one from lithium, it now has 8. Okay? And fluorine, when it gains an electron, will get a negative charge. And now its electron arrangement becomes 2 and 8. And so it has a fully filled first and second energy level. Okay, and therefore it's stable. So here is the periodic table with a list of some of the charges for different groups. For now, like in the past, we're going to ignore the transition metals. But if you notice in that first group, all of them have a +1 charge, which means that they lose 1 electron. And typically you won't see the 1 represented. You're going to see it just as a simple plus sign. Now in column 2, it's going to have a +2 charge, which we tend to write this as 2+. And then skipping the transition metals and coming over to the 3A group, those will tend to have a 3+ charge. And then carbon, sometimes you'll see it as 4+ or 4-, depending on the periodic table that you look at. But here we're going to go with 4-. And again, you don't deal with that one too much in this class. And then afterwards, it becomes easier to gain electrons because we're getting closer to that fully filled outer shell. And so the next column will typically be a 3- charge, and then a 2-, and then a 1-, which is typically represented as just a negative charge. And then that last column, they prefer to be neutral. They already have fully filled electron arrangements, and so those tend to have a 0 charge or neutral atoms. So let's practice determining the number of protons and electrons in each ion. And if we remember, the number of protons are determined by the atomic number. And the number of electrons are going to depend on the charge and the number of protons. So it depends on the number of protons and the charge. Okay, so it'll be easier if we first determine the number of protons in each ion. So looking at the periodic table for calcium and chlorine, calcium here has an atomic number of 20, chlorine on the right-hand side an atomic number of 17. So that means calcium has 20 protons and chlorine has 17 protons. So the number of protons for each, calcium we said was 20 and chlorine 17. And then aluminum and chromium, aluminum on the right-hand side is 13 and chromium in the middle is 24. So aluminum has 13 protons and chromium 24 protons. And then the last one, nitrogen, up at the top on the right-hand side, we have 7. Okay, so remember that the number of protons comes from the periodic table. Now, to determine the number of electrons, we're going to need to take the number of protons and either subtract or add based on the charge. So remember that we said positively charged ions, those lose electrons. And negatively charged ions gain electrons. So that means if we're dealing with a positively charged ion, we need to subtract based off of the charge. And for negatively charged ion, we need to add electrons to the system. So for positively charged ions, you should have less electrons than you do protons. So the number of electrons should be less than the number of protons. And then for negatively charged ions, the number of electrons should be greater than the number of protons. So that's a good trick to help yourself check and see if you got the right answer. Okay, so calcium is a positively charged ion. Therefore, what we're going to do is take the number of protons that we have, which is 20, and subtract from it 2, based off of that charge of 2 plus. And 20 minus 2 gives us a total of 18. Okay, chlorine is negatively charged ion, so therefore we need more electrons than what we have as protons. So we're going to take 17, and because that's a -1 charge, we're going to add 1 electron, giving us a total of 18. Aluminum at +3, again, positively charged ions, we need to have less electrons. So therefore we take 13 minus the charge is 3, so -3. And that results in 10. Chromium +6, again positively charged, we need to subtract. So 24 minus the 6 from the charge. Okay, and gives us a total of 18. And then nitrogen, the last one, is negatively charged, therefore we need to gain electrons or add, and therefore you have 7 plus 3 from the charge, gives us a total of 10. And if you notice, most of those numbers are either 10 or 18. And if you are dealing with main group elements, typically the number of electrons should match one of the atomic numbers in the last column of the periodic table. So if you notice, neon is 10 and argon is 18, and all of our answers are either 10 or 18. Okay, the last thing I want to talk about in this video are polyatomic ions. We're just going to briefly cover what they are, and then in the next video, we'll talk about how to name them. Okay. Polyatomic ions are going to consist of a group of atoms that are bonded together. Okay, so you have to think of these like they're a package deal. It's for carbonate, it's not just carbon or it's not just oxygen. It is technically CO3 2-. Okay, and that's a whole package. And if you notice, you can see it's a group of atoms that are sort of permanently bonded together. And when we start looking at formulas, we're going to make sure to put parentheses around these. Now, in order to learn the charges, it's not as simple as looking at the periodic table. You're going to have to memorize these charges. All right, so in the next video, we will pick up with naming monoatomic ions, which is what we looked at the beginning, and these polyatomic ions. Remember to subscribe in order to see more videos.